Have you ever wondered how a simple gust of wind can light up an entire city? It's a fascinating concept, isn't it? Well, the secret lies in the power of wind energy. You see, wind is actually a form of solar energy. How so? Well, it's all about the sun's heat and the way it interacts with our planet. The sun doesn't heat the Earth evenly, and when you throw in the irregularities of the Earth's surface, things get really interesting. Some areas heat up faster than others, causing air to rise and creating areas of low pressure. Cooler air rushes in to fill these gaps, and voila, we have wind. And let's not forget the Earth's rotation, which also plays a part in directing the wind's flow. So, we have this constant renewable energy source that's always around us. Harnessing this natural, renewable, and abundant resource is where our journey begins. A wind turbine may look simple from afar, but it's a marvel of modern engineering. Look beyond its soaring height and rotating blades, and you'll find a complex network of components, each playing a crucial part in the conversion of wind into usable energy. Let's start at the top, with the most visible part of a wind turbine: the blades. These aren't just for show. Shaped like airplane wings, the blades harness the kinetic energy of the wind and convert it into mechanical energy. The wind pushes against the blades, causing them to rotate, much like how a fan spins when you blow on it. Attached to the blades is the rotor, which is essentially the heart of the wind turbine. The rotor connects the blades to the main shaft, which spins as the blades rotate. The spinning rotor is where the magic starts, transforming kinetic energy into mechanical energy. But the rotor alone doesn't generate enough power to produce electricity. That's where the gearbox comes in. Acting like the transmission in your car, the gearbox amplifies the rotations of the main shaft, increasing the speed before it reaches the generator. This high-speed rotation is essential for the next step in the process. Finally, we reach the generator, the last major component in our wind turbine. Inside the generator, the high-speed rotation of the shaft creates a magnetic field, which induces an electric current. This current is what we use as electricity, ready to power our homes, businesses, and more. In essence, a wind turbine is a giant, sophisticated windmill, using the same principles that have powered human civilization for centuries, yet it's evolved into a high-tech machine that can generate massive amounts of clean, renewable energy. Each part of a wind turbine plays a crucial role in harnessing the power of the wind, but how does it all come together? Well, that's a story for the next scene. Stay tuned as we dive deeper into the process of wind energy conversion. The journey from a gust of wind to a spark of electricity is a fascinating one. Let's dive right into it. At the heart of this journey is the principle of energy conversion. You see, energy can neither be created nor destroyed, but it can be transformed from one form to another. And that's exactly what happens within a wind turbine. It all begins with the wind. When a gust of wind blows, it doesn't just move the air around, it carries kinetic energy with it. This kinetic energy is what gets the ball rolling, so to speak. As the wind blows, it comes into contact with the blades of a wind turbine. These blades are designed to capture as much of the kinetic energy as possible. The captured energy then sets the blades in motion, causing them to spin around much like a gigantic fan. The spinning blades are connected to a central hub known as the rotor. As the blades spin, so does the rotor, but the rotor doesn't spin aimlessly. It plays a crucial role in the energy conversion process. Attached to the rotor is the generator, the magic box that turns all that kinetic energy into electricity. When the rotor spins, it causes the generator to spin as well. Inside the generator are coils of wire and magnets. As the generator spins, it creates a magnetic field that induces an electric current in the coils of wire. This electric current is what we commonly refer to as electricity. This electricity is then directed through transformers to increase its voltage, allowing it to travel long distances without losing much energy. From here, it is fed into the grid and distributed to our homes, schools, and workplaces, powering the devices and appliances we use every day. And that, in a nutshell, is the process of wind energy conversion. From the wind blowing in the fields to the light in your study room, it's a process that harnesses the power of nature to bring us clean, renewable energy. And just like that, a gust of wind has been transformed into usable electricity. But what makes this process so beneficial for our environment? With the pressing need for sustainable energy sources, wind energy stands out as a champion. But why is this so? let's dive into the environmental benefits of this increasingly popular form of renewable energy. First and foremost, wind energy is renewable. This means that unlike coal or oil, we're not going to run out of it. Wind is a naturally occurring phenomenon that's abundant across the globe. As long as the sun continues to heat the earth unevenly, causing air to move and create wind, we'll have a steady supply of this energy at our disposal. Now let's talk about emissions, or rather, the lack thereof. Wind energy is clean. When a wind turbine spins its blades and generates electricity, it doesn't release harmful pollutants into the atmosphere. No carbon dioxide, no sulfur dioxide, and no nitrogen oxides. This is a stark contrast to the emissions produced by burning fossil fuels, which contribute to air pollution and climate change. Additionally, wind energy helps us reduce our dependence on those very fossil fuels. Every kilowatt-hour of electricity generated by a wind turbine is a kilowatt-hour that doesn't need to come from coal or natural gas. This not only conserves these non-renewable resources for other uses, but also prevents the environmental damage associated with their extraction and use. Wind energy also requires relatively little water to produce compared to other energy sources. This makes it a more sustainable choice in regions where water resources are scarce or need to be conserved. Finally, while wind turbines do require space, they coexist well with other land uses. A wind farm can share its land with agricultural activities, for instance, allowing for a harmonious blend of energy production and food cultivation. In essence, wind energy is a triple win. It's renewable, it's clean, and it's abundant. It has the potential to help us significantly reduce our carbon footprint, lessen our reliance on fossil fuels, and contribute to a healthier planet. Wind energy doesn't just light up our homes, it lights the way to a sustainable future. The story of wind energy is still being written, with exciting chapters ahead. Wind energy, like any form of renewable energy, is a dynamic field with endless potential for innovation and advancement. We're not just talking about building taller turbines or spinning faster blades. We're looking at revolutionary breakthroughs that could redefine the way we harness the power of the wind. Consider the global investment in wind energy infrastructure. It's been growing at an unprecedented rate. Countries around the world are recognizing the immense potential of wind energy and are investing billions to tap into this clean, renewable power source. This investment is not just about erecting wind turbines, it's also about creating a robust infrastructure to support the generation, storage, and distribution of wind energy. Now let's set our sails towards the vast, unexplored potential of offshore wind farms. These are not just bigger versions of their land-based counterparts. They're sophisticated marvels of engineering capable of harnessing the powerful, consistent winds that sweep across the ocean's surface. And the best part? There's plenty of space out there. With the right technology and infrastructure, offshore wind farms could provide a significant portion of our global energy needs. But it's not just about generating power. It's about doing so sustainably. Wind energy plays a crucial role in reducing carbon emissions. Every kilowatt-hour of wind energy we produce is a kilowatt-hour that doesn't come from burning fossil fuels. As we continue to innovate and invest in wind energy technology, we can expect this impact to grow, helping us move closer to a carbon-neutral future. The power of the wind is more than just a breath of fresh air. It's a gust towards a greener, cleaner future for all.